Great. Next slide. So just as a reminder for those of you that aren't aware or know what Lunar-Vise is, Lunar-Vise is the Lunar Vulcan Imaging and Spectroscopy Explorer that was selected as part of NASA's second PRISM call. And we were selected to fly as part of CP21. And this is a 10-day surface investigation where our main goal is to really understand how these silicic volcanic features form on the moon. Next slide. As we also heard this morning in many of the talks, we now have our ride to the moon, which we're really excited about. So it was announced in December of 2024 that Firefly will be carrying us to the surface of Gruithuisen Gamma, where we'll be conducting our science investigation. And so that will be Blue Ghost Lander 3. And we have a rover from Blue Origin and Honeybee Robotics that will allow us to do our surface investigation. Next slide. To enable our science objectives and to really be able to answer our science questions, we have two main payloads on the rover. We have the Lunar-Vise Visible Infrared Multiband Suite, or LV-VIMS, which incorporates two multispectral cameras. So we have a multispectral visible as well as a multispectral thermal camera. And you can see that sitting on top of the rover there. And then we also have the Lunar-Vise Gamma Ray and Neutron Spectrometer, or LVGRNS, that will be located on the back of the rover, so you can't see it quite on this image. Next slide. We're going to use those two main instruments to really get at the composition, and when I say composition, I mean mineralogical as well as elemental composition of the rocks and regolith across the dome. We'll also be using the thermal infrared instrument to get at the thermophysical properties of that rock and regolith. And then most importantly, we'll also be using our data that we've collected from the rover to ground truth all of the multitude of remote sensing observations that we've collected over the years. And that will be a really important aspect of our mission of tying what we're measuring at the dome to what we have seen in orbit. So that allows us to take what we know at Gruithuisen and apply that to the other silicic volcanic spots. Next slide. To kind of show off some of our instruments, we have some images of our actual instrument payloads here. So we have the Visible Infrared Multiband Suite, or LV-VIMS. You can see on the left, we have the two sensors for the visible camera on top, and then the sensor for the thermal camera on bottom. In the middle, you can see both of those sensors have been mounted with the rest of their cameras and put on the lid of their single enclosure that they share. And then on the right, you can see the fully assembled instrument on the vibe table, ready for vibe testing. Next slide. We also have here now the fully assembled flight and flight spare gamma ray sensors, as well as the neutron sensors, which will be pulled together for our GRNS system. And so you can see that we are making great progress in building and assembling these instruments. Next slide. To achieve our exploration goal of really understanding the geotechnical properties across the volcanic feature, we will be using two cameras. We'll be having one camera that is nadir facing on the lander as we're coming into the landing site, and that's the descent camera. And then we'll also have a camera, the context camera, that'll be sitting on top of the lander that will give us images of the landing area throughout the lunar day. And you can see the context camera in this image of the lander sitting up on the boom. And so it looks very much or very similar to LV-VIMS in this context. Next slide. And so we'll be using the context and descent cameras to really we'll get an image of our landing site, which will enable us to build up a geologic map of the area and to have a good understanding of where we want to traverse and where we want to pick our waypoints. We'll also be using that data to also understand, most importantly, how the regolith is affected as the lander is coming into the landing site, and then also how the rover and its wheels interact with the regolith as it's moving across the domes. And so we'll really enable our investigations into understanding the geotechnical properties. Next slide. And then here we have some images of those cameras. On top, we have the descent camera image, or the descent camera, and then on the bottom we have the context camera. On the left, we have cameras themselves. In the middle, we see them partially assembled in their enclosures. And on the right, you see the fully assembled flight instruments, and those are undergoing EMI testing in these images. Next slide. Now, it's especially exciting to share, since we're so close to the Apollo 11 anniversary of the landing, to announce that we put in a proposal to name the crater that is at our CP-21 landing site. And so if you look in the image on the right, you'll see this approximately 150-meter diameter crater, and you can see our landing site and our notional traverse to the upper right of that crater. And this crater is really important because it has exposed a large boulder field that we're really interested in studying. And that is where we're going to rove to really get at our science questions. And we proposed Moreda as the name in honor of Moreda West. And you'll see Moreda West on the right, or sorry, on the left in this image. And Moreda West was a geologist. Initially, she was a petroleum geologist who had gotten her BS in geology at the University of Oklahoma, but then after 11 years, transitioned into doing work for the USGS, and in particular, she was the first woman on NASA's geology experiment team for picking the landing site for the Apollo 11 mission, and then was later involved in helping select the landing sites for the other Apollo missions. And so this is an IAU-approved name, and so everyone may now start using Moreda Crater when referencing our landing site. Next slide. So where are we at now? As I mentioned, we now have a ride to the moon, which we're really excited about. We are undergoing final assembly of all of our instruments, as well as undergoing vibe, environmental, and functional testing. We are on track for delivering our instruments in place in December of 2025. And we are still working to characterize our landing site and working with Firefly and Honeybee to really come up with a best operations plan. And you should be on the lookout for 2 papers led by Pierre Williams that are describing how we went about selecting our landing site, but then also the characteristics of the landing site. And those should be coming out in the near term. They're currently undergoing USGS review. Next slide. And then just to highlight some of the other presentations this week that you'll see from the team, we have 2 talks from team members, Elena Dolgus, who will be talking later this afternoon about silicic volcanic constructs. We have Kristen Bennett giving a talk about some field work in Wildcat Hills, characterizing lunar analogs here on Earth. And then we have some posters that will be tomorrow night. And so with that, thank you.